The historical ledger loves a pristine fairy tale. We are taught to look at the monuments of the past as elegant victories of 19th century engineering. They tell you that the Eiffel Tower is the romantic symbol of Paris, a structure assembled with the flawless, effortless precision of a giant mechanical puzzle. Open any textbook, and you will find the exact same sterilized corporate statistics. 2 years, 2 months, and 5 days. That is exactly how long it took to erect what was then the tallest artificial structure on the planet. 18,038 individually forged iron pieces, 2.5 million rivets, and, according to Gustave Eiffel's corporate ledger, throughout the entire grueling process, there was only one single official fatality. Flawless logistics, perfect mathematics, a bloodless triumph of the industrial age. But mathematics is rarely bloodless when you are attempting to cheat gravity and time. You do not build a 300-meter iron needle in the 1880s with pure romance. At the TitanMetrics Audit Desk, we do not evaluate tourist brochures. We audit thermodynamic warping, the crushing atmospheric pressure of pneumatic caissons, and the biological breakdown of undocumented workers. Open the ledger.
Gustave Eiffel's legendary myth rests heavily on one fundamental claim. The tower was built with impossible speed because absolutely every single component was prefabricated off-site. At his factory in Levallois-Perret, draftsmen generated over 5,000 detailed blueprints. The official story claims that every piece of iron was calculated, cut, and pre-drilled to a tolerance of 1/10 of a millimeter. They were transported to the Champ de Mars, ready to go. The men on site simply had to hoist them up, align the holes, and drive the rivets. It sounds like the birth of the modern, frictionless assembly line. But here is where theoretical engineering violently collides with the gritty reality of 19th century construction. This beautiful theory completely ignores one critical, undeniable variable: the material itself. The Eiffel Tower is not built from modern, weather-resistant steel. It is built entirely from puddled iron. Puddling is an obsolete, grueling metallurgical process. It creates a tough structure, but it has one specific characteristic that turns a flawless factory assembly into a logistical nightmare: a massive coefficient of thermal expansion. Imagine a structural iron beam, 15 meters long, drilled inside a cool factory at 10 degrees Celsius. Now that same beam is transported to the site in the blistering heat of July. The ambient temperature hits 35 degrees. The direct sunlight hits the dark metal. The iron absorbs the heat, and it physically expands. Those perfectly aligned rivet holes, drilled to a fraction of a millimeter back at the factory, no longer align. But it gets much worse. The sun does not heat a 300-meter tower evenly. It bakes the southern and eastern faces of the structure, while the opposite sides remain cast in cool shadows. The heated iron expands. The shadowed iron contracts. Because of this massive thermal imbalance, the entire skeleton of the tower literally bends. Even today, under the heat of the summer sun, the apex of the Eiffel Tower sways and shifts away from the sun by up to 18 centimeters, carving a slow ellipse in the Parisian sky.
Now, travel back to 1888. You are a structural foreman, standing on a narrow plank 150 meters in the air. A steam-powered crane lowers a massive iron truss down to your team. You need to align 20 pre-drilled holes on that truss with 20 holes on the main supporting column. But the column you are standing on is warping from solar radiation. and the truss swaying on the crane cable has expanded in the heat. The holes are misaligned by several millimeters. In the unforgiving world of rigid iron frameworks, a 3 mm misalignment means you cannot insert the rivet. The assembly is paralyzed. So how did they solve this thermodynamic puzzle without modern lasers? Eiffel knew the sun would warp his tower, so he engineered a brutal mechanical workaround at the very base of the structure. Hidden inside the masonry foundations of the 4 massive legs were 16 custom-built hydraulic jacks. Each jack was capable of lifting 800 tons of dead weight. When the thermal expansion warped the tower out of alignment, workers in the dark foundations manually pumped these hydraulic presses. They physically lifted and tilted the entire thousands of tons of the iron lattice structure, shifting the angle of the tower until the holes in the sky perfectly aligned. Once the rivets were driven, the jacks were lowered. To make micro adjustments, Eiffel used sandboxes. Heavy iron cylinders filled with dry sand supported the beams. By opening a small plug and letting a few grains of sand bleed out, they could lower a 500-ton column by a fraction of a millimeter. It was not a gentle assembly. It was a daily, exhausting, violent war against the laws of thermodynamics, fought with water pressure and crushed sand.
But the most terrifying physiological audit of this project isn't found in the sky. It is buried deep underground. For a 300-meter iron needle to withstand the sheer kinetic force of a winter gale, it required an absolute monolithic foundation. 2 of the tower's massive legs rested on solid, load-bearing gravel, but the other 2 legs, facing the Seine River, had to be planted in unstable, waterlogged mud and shifting quicksand. Digging standard foundation trenches was physically impossible. The groundwater from the Seine would instantly flood the excavation pits, turning them into bottomless swamps. To conquer the river mud, Eiffel resorted to a brutal technology that had already left a trail of paralyzed bodies during the construction of the Brooklyn Bridge: pneumatic caissons. It is right here, deep in the mud, that the corporate ledger of 0 fatalities begins to fracture. A caisson is essentially a colossal, bottomless steel and wooden box, the size of a multi-story building. This massive trap was sunk directly into the mud on the banks of the Seine. To keep the river from flooding the box, massive steam-powered compressors on the surface continuously pumped highly compressed air down into the chamber. The atmospheric pressure inside the box was so intense that it physically forced the groundwater back down into the earth, creating a dry, artificial pocket. Inside this pressurized steel tomb, 15 meters below the riverbed, were the diggers, men working with shuttles, pickaxes, and raw muscle, excavating the muck from beneath the edges of the box, forcing the colossal structure to slowly sink until it hit solid bedrock. Let us run the biomechanical analysis of a caisson worker. To keep the water out at a depth of 15 meters, the compressors had to maintain over 2 atmospheres of absolute pressure. The human body is a fragile biological engine. It was never designed to operate under such crushing, abnormal pressure.
When a worker entered the airlock to descend, the compressed air crushed against every square inch of his skin, pressing against his eardrums, forcing its way into his lungs. The air inside the caisson was baking hot from the friction of the mechanical compressors, often exceeding 30 degrees Celsius with 100% humidity. It was a dark, suffocating, claustrophobic cave. Men stood knee-deep in sticky, foul-smelling river sludge, swinging pickaxes in an environment that felt like breathing hot soup. But the real horror of the pneumatic caisson didn't happen in the mud. It happened when the men tried to leave. When a human breathes highly compressed air, the gases, specifically nitrogen, dissolve into the bloodstream and human tissue. While you are at the bottom of the caisson, under pressure, you don't feel it. Your blood simply absorbs the gas, exactly like liquid inside a sealed, pressurized bottle of soda. But when the 12-hour shift ended and the exhausted worker stepped into the airlock to return to the surface, the atmospheric pressure was rapidly released. And then, physics takes over. When you pop the cap off a warm bottle of soda, thousands of carbon dioxide bubbles instantly, violently expand and rush to the surface. That exact same violent expansion occurred inside the veins, arteries, and spinal fluid of the French workers. The dissolved nitrogen literally boiled inside their blood. These expanding gas bubbles acted as macroscopic blockages. They tore through capillaries in the brain. They pooled in the joints, causing an agony so profound that medical journals described it as the sensation of having your bones crushed from the inside out by iron pliers.
Today, we call this decompression sickness. In the 19th century, they called it the caisson disease, or simply the bends. The symptoms were horrific. A worker could step out of the airlock, light a cigarette, and within 60 seconds, collapse to the dirt, convulsing in agony. Many lost all sensation in their legs. Nitrogen bubbles lodging in the spinal cord caused irreversible, permanent paralysis. If a bubble blocked a major artery to the heart, the worker died in excruciating pain. Gustave Eiffel's official corporate history proudly states 0 deaths during the excavation phase. But 19th century engineers were fully aware of caisson disease. They just did not have accurate, medically verified decompression tables. The time workers were allowed to spend in the airlock depressurizing was fatally short. For the corporation, keeping an airlock occupied for 2 hours of slow depressurization was inefficient. It delayed the removal of dirt. It threatened the holy exhibition deadline. So they flushed the men out too fast. Those who collapsed, crippled, and paralyzed were simply dismissed. Their names were erased from the active payroll. They were not recorded as on-site fatalities because technically they didn't die crushed by a beam on the Champ de Mars. They died weeks later from pulmonary embolisms in cheap charity hospitals, or they lived out the rest of their short lives paralyzed in the slums of Paris. They were written off as broken tools.
We have audited the foundations and the thermodynamics. Now let us climb back up the iron skeleton and analyze the central mechanism that holds this monster together, the riveting process. There are 2.5 million rivets in the Eiffel Tower. Over 700,000 of them were driven manually, on-site, high in the air. How was this done in 1888? There were no pneumatic rivet guns. There was no electric arc welding. There was only fire, raw iron, and human muscle. Driving a single structural rivet required the flawlessly synchronized choreography of a 4-man team. First, the heater boy operated a glowing coal forge on a wooden plank. He heated a thick iron rivet until it reached roughly 900 degrees Celsius. He grabbed it with iron tongs and threw the molten metal across the open air. Second, the catcher. Standing on a beam with nothing but empty space below him, he tracked the glowing projectile, caught it in a tin funnel, and shoved it through the aligned holes of the iron girders before it began to cool. Third, the bucker threw his entire body weight against the flat head of the rivet using a heavy, solid iron bar to hold it in place. And finally, the striker, the most physically depleted man on the crew, wielding a massive sledgehammer weighing up to 5 kilograms. While the iron was still glowing red, he had to deliver a rapid succession of devastating, perfectly accurate manual strikes to the exposed end of the rivet. He crushed the metal, mushrooming it out to form a second head. As the iron cooled, it contracted, violently clamping the two massive girders together with immense permanent tension. Now, let us run the TitanMetrics calculator. It took a skilled 4-man crew roughly 3 minutes to properly set a single rivet. To drive this staggering volume of iron before the World's Fair deadline, dozens of these gangs had to work simultaneously, 10 hours a day, 6 days a week.
Calculate the physiological attrition rate of the striker. Swinging a 5-kilogram hammer with maximum kinetic force, striking a target the size of a coin, while standing in an unnatural stance on a swaying iron beam. Dozens of swings per rivet. Hundreds of rivets per shift. It is a level of extreme cardiovascular and muscular deterioration comparable to running a marathon every single day while carrying heavy weights. And they did this exposed to blistering solar radiation in the summer and freezing gales in the winter. When muscles flood with lactic acid, when human concentration falters for even a fraction of a second, a sledgehammer slips, or the catcher makes one awkward lunge to trap a piece of molten iron, shifting his center of gravity too far. Mainstream historians love to aggressively defend Gustave Eiffel here. They point to archival photographs showing large wooden platforms and safety nets spread out beneath the workers. They praise him as a pioneer of industrial worker safety. At the TitanMetrics Audit Desk, we look past the corporate PR. Yes, there were nets, but who installed them? Who had to balance on the raw, slippery iron hundreds of meters in the air to rig those very platforms? Safety existed for the government inspectors, the journalists, and the riveting gangs who followed behind. But for the vanguard, the initial iron erectors, it was a daily dance on the edge of the abyss with zero protection. And the workers knew it. In September 1888, as the tower crossed the terrifying 150-meter mark, the biological engines began to fail. The freezing autumnal winds were lethal, and the descent to ground level for meals wasted precious kinetic energy. The workers went on a massive strike. They demanded hazard pay for the extreme altitude.
Gustave Eiffel's response was a masterclass in corporate ruthlessness. He agreed to a minor base pay bump, but flatly refused any hazard pay. He officially stated that the risk of falling was exactly the same at 50 meters as it was at 200 meters. Those who continued to demand hazard pay were fired on the spot. They were replaced within hours by fresh, desperate men from the Parisian slums. To the corporation, human biology was just another highly expendable resource. And even if a worker survived the falls, the freezing winds, and the exhaustion, the corporation had one final, undocumented biological trap: the paint. The original Eiffel Tower was coated in 60 tons of heavy, highly toxic lead paint. It was applied entirely by hand. Men stood on the iron framework with brushes, inhaling concentrated lead dust for 10 hours a day. Heavy metal poisoning is a slow, agonizing death that systematically destroys the nervous system. But because the neurological collapse happened years after the World's Fair ended, it never appeared on Eiffel's flawless construction ledger. Another ghost in the machine. The official corporate ledger claims only one man died during the entire build, an Italian worker named Angelo Scagliotti, and supposedly he fell off the clock, showing off for his girlfriend. A perfectly sanitized narrative that legally absolved the corporation of any liability.
The Eiffel Tower is not just an architectural triumph. It is a towering monument to how corporate willpower, driven by unforgiving deadlines, will systematically ignore the limitations of physiology. When you look up at that elegant, interlaced iron lattice, you are looking at a blueprint. But blueprints do not bleed.
Blueprints do not suffocate from nitrogen bubbles in compressed air chambers. Blueprints do not inhale toxic lead dust while swinging a sledgehammer at 200 meters. This structure wasn't built by mathematical theory alone. It was forged by the brutal, relentless consumption of human flesh, a truth conveniently redacted from the sanitized history books. But if you think 19th century Europe was the absolute peak of industrial cruelty, you are severely mistaken. Because decades later, across the Atlantic, an American syndicate decided to stack 57,000 tons of steel into the Manhattan sky in just 410 days. They created a vertical assembly line with absolutely zero safety nets, forcing human biology to absorb the catastrophic kinetic trauma of 38,000 pneumatic hammer strikes per minute. And they covered up the resulting biological deficit using a grim hospital loophole. The forensic audit of the Empire State Building's 410-day meat grinder is opening on your screen right now. The ledger remains open,